Okay, today we're gonna be looking at the bubble sort. So the idea of bubble sort is that we're gonna take an array, obviously unordered array, and we're gonna look at the element that we are pivoting, and then we're gonna be comparing the element next to the element that we're looking at. So we're gonna compare 4 and 4, and if that is out of order, whether it's a descending order or ascending order, we're gonna swap it, and then we're gonna be iterating all the way through the end of an array, and then until when we do enough of the iteration, at the end of the iteration, we'll have end up having an ordered, whether it's a descending ordered or ascending ordered array. So, like for example, when we do this one, the one that I had an example, so we're gonna do is 4. We're going to be comparing with the 4. Well, 4 and 4 are equal, so we don't have to do anything. So I'm going to move on to the next one. 4 and 5, let's assume that we're going to do in an ascending order. So 4 and 5, that is also, it doesn't have any problem, but the 5 and 3 actually does have problems. So we're going to be swapping it for with 3 and 5. So it's going to be 3 and 5. Okay, let's put that in there. And then here we were at 5, we are comparing with 5 and 6, no problem. 6 and 7, no problem. And 7 and 9, no problem. But then this is not being ordered yet. So we're going to be doing again in the beginning and doing the same thing until the array is indeed ordered. So let's put that in Ruby. So here first we are going to define the default proc. In case a user does not put in any proc in there, and that is going to be we're going to be defining a proc in ascending order. So here x and y, x spaceship operator and y. So the difference between the bang and the not bang is that the bang will actually mutate the array that we are calling from. So if we're actually calling from, say, like a dot bubble sort bang, after so when we call the bubble sort bang, we're gonna mutate the a. So what we started before the bubble sort and after the bubble sort, the a is gonna have a different value. So that's where the bang comes from. And so, okay, so we defined the proc, and let's actually start declaring a variable sorted is equal to false. It's going to be a boolean, whether it's going to tell us whether the array is sorted or not, but then we start with a not sorted array, and that obviously makes sense. And next we're going to be iterating until sorted is equal to true. We're are going to iterate it and see if everything is sorted. So until sorted, let's close that. We are going to artificially set the sorted value is equal to true. And here we'll be iterating from 0 to in a range of self.length minus 1. Well, this is actually a range, and when we have 0 to self.length, we're actually indexing the array that we have passed on to. So usually it's always the last index number will not reach the length, the array length. It's going to end 1. It's going to be one smaller than the length of the array. So we actually don't include that. That's why we have an extra dot here. But then minus 1 here. So we're actually going to end at the second to the last element here. And you're going to see why on the next line I'll be explaining. So dot each do index. So if proc dot call. So here's self of index, and we are actually comparing with the next element of the index, which is the self of index plus 1. So here is why we subtracted minus 1 here, because when we actually don't subtract minus 1, we're going to be looping until the last element over here, and when we are comparing the last element with the next element, which is nil, this is not going to work. This is going to return nil, and this is going to throw an error. So that's why we want to stop in the second to the last element, because when we're actually stopping at the second to the last element, it's going to compare with the last element in this line. So if this is greater than 0, which means it's out of order, we are going to simply switch self.say index comma self.index plus 1 is equal to self of index plus 1 comma self of index. So this is very, very useful and easy Ruby syntax, where when you have a comma b is equal to b comma a, we're just gonna swap from with a and b to b and a. So we're just swapping a and b in places. If you work in another language, you're gonna have to set a to a third variable, like and then set b into a, and the third variable into b. We're gonna have a lot of steps, but then Ruby actually gives us a very nice one-line syntax where we can swap two elements. So please do take advantage of that. I'll be putting over here. And when we actually swap it, we know that it wasn't sorted. So we're going to say sorted is equal to false. So that at the end of the iteration, inside the iteration, we are going to actually take a look at, we're going to do another looping and see if everything is sorted. So yeah, at the end of if there isn't any case that we're gonna have to swap it, that means if the if statement was never true, we will have the sorted is equal to true at the end of the iteration. So when we hit the until sorted loop, we will actually get out of the loop, and presumably we're gonna have sorted arrays. And lastly, we'll be returning the self, because when we finish swapping all the elements when that is not sorted, we're going to have a sorted array. So let's test that. So I am in terminal. I'll go to pry. Are we in right folder? Yes, we are. So let's load bubble sort.rb. So I'll take, say, a is equal to, I don't know, 5, 3, 7, 6, 8, 3, 2. Okay, first I'm going to do a.bubble sort bang without any proc. That means we're going to do an ascending order. So yep, that is being taken care of. So let's see if we mutated the a. Yes, we started with 5, 3, 7, 6, 8, 3, 2. Now we mutated with the bang sign there with 2, 3, 3, 5, 6, 7, 8. And let's see if this one works with descending order. So y spaceship operator x. Cool. Now we have a descending order of an array, and the a is actually being mutated. So this one works. So let's go ahead and work on the next one, which we're not going to mutate the original array that we have passed on to. So all you need here is just declare or define a separate variable. We're going to do array is equal to self.dub. I'm assuming the dub came from the duplicate. Some people call it dupe. Some people call it dub. It doesn't really matter what you call it. But what dub does is that it's just gonna duplicate the array that we pass on to. So array, so the R variable is completely, well, it's gonna have the same values, but it has a different object ID than the self. So here, everything else is gonna be exactly the same. We're gonna be lazy defining. We're going to be defining the proc in a lazy manner. So proc.new x comma y x spaceship operator y and we're going to start with sorted is equal to false, and we're going to loop until sorted, artificially assigning sorted is equal to true, and then we will loop it through array.length this time -1 because we want to stop at the second to the last element here. So do each idx. So let's call proc. Let's do array of index comparing with the array of the next element is greater than 0, which means it's out of order. Let's swap it with the nice easy Ruby syntax that we have. +1 is equal to array idx +1 comma array idx. Okay, and then when we swap it, we know that this is not being sorted. Nope, going too fast. And finally, we want to return the array right here. So let's save that. Let's load a bubble sort $rb. Oops, nope. Let's do this. Okay, I'm gonna say b is equal to another array. Let's say 7, 4, 5, 3, 6, 9. I don't know, 2. Okay, so let's do b.bubble sort without any bang, without any proc, which we'll get. We'll have a sort ascending array in return. So we indeed have array that is in ascending order, but we have not mutated the b. The b remains the same as what we initially defined. But then when we call it, it actually gives us the sorted array. So let's do another way of sorted sort in descending order. Y versus spaceship operator x. So when we do it, boom, we have a descending order array here, but we have not mutated the original array that we passed on to. Yep, so this is how you want to work on the bubble sort. Particularly, obviously, we are doing a lot of iterations, so this is very practically very inefficient sorting algorithm compared to the quick sort or the merge sort, where we can divide it into the array and then work on separately. So this is generally very inefficient sorting algorithm that actually does the nested iterations. So the big O will be, in this one, will be 2 to the second power. No, n to the n squared. Because we are actually iterating, we are doing a nested iteration in here and inside here as well. So this is very inefficient sorting algorithm, but for a beginner, it's a great way to learn logic and how sorting works in a different way. So yeah, this is your takeaway, and that's it for me.